Now, this question deals with area and volume, but before we start dealing with questions on area and volume, let's take a look at what we should be doing when dealing with such questions. Right, number one, we will need to sketch the graphs required, all right, as a guide. Right. Secondly, we need to identify the region described based on the boundaries. Okay. And thirdly, formulate the integral and evaluate. All right. Now, if you are dealing with volume, there are a few more things you need to talk about. Firstly, you need to know where's the axis of rotation. You'll also need to know the angle of rotation. Here we will talk about it later on in the question itself. Okay, let's begin question 3. Let's see how we apply all these. But the only thing is, for the sketching is provided in this question. The diagram given to you is quite comprehensive. All right, the given diagram shows the region R enclosed by the curve of 4y squared equals to 1 minus 1 over x squared. Right, the x-axis, the y-axis, as well as the line y equals to 1/4. So in totality, there are actually 4 boundaries given to you. Now let's take a look at how each of them, right, would eventually tell you about the region R. Okay, that means if you are given the description, how do you tell that in the end that is actually R you're talking about? Okay, the curve was described. The x-axis was the next one. The next telltale sign was y-axis. And lastly, the line y equals to 1/4. Now, look at the diagram. Which region is bounded exactly by the 4 boundaries described? Okay, it must be bounded by all 4 to be considered the described region. Okay, it will have to be this portion, okay, that was shaded in red as shown on the screen. So now, if I remove the 4 boundaries, you'll notice that that is actually the region R that we are talking about. Okay, that was given to you right at the start of the question. Okay, now with this understanding, we can now begin. Part 1 is to find the exact value of the area of the region R. Now, after defining or identifying the region, we need to formulate the integral, right? But to formulate the integral, we need to look at how we can look at this particular region and formulate the integral for the area. Now, remember in your lectures, we can actually either integrate with respect to x or with respect to y. Each of them actually points to different ways of formulating the rectangle. Okay, now if you were to stack the rectangles together, actually the easiest way, all right, to look at the area of R is to find a representative rectangle that is horizontal. All right, if you take a look at the whole region of R, you can actually find similar rectangles that in the end, when you sum all the areas of that rectangle and limit it, it will become the area of this particular region. All right, so let's take a look at this particular rectangle that represents all the rectangles in the region. Now, there's a length here. What is the length? This point is actually xy that is given on the curve itself, and this point is actually 0y, right? So if we take a good look, this would actually be x minus 0, which is x. And the breadth of this is actually delta y. Therefore, the area of this rectangle is actually x, which is the length, times breadth delta y. Okay, so what is this x about that you see here? It is actually the relationship of x and y, right, that is governed by the equation of the curve. Okay, so that tells you that we need to find what is x in terms of y, because later on we are actually going to integrate with respect to y. All right, without further ado, let's begin this part. So given, okay, we know that we need to find the expression of x, right? So given 4y squared equals to 1 minus 1 over x squared, we know that 1 over x squared equals to 1 minus 4y squared. So this means that x squared equals to 1 over 1 minus 4y squared. Now, to find x, you need to know what are the values of x here. We know that x is positive, so therefore, not therefore, since, okay, since x is positive, x will then be 1 over square root 1 minus 4y squared. Okay, now just a quick recap. If you have a quadratic x squared equals 1 over 1 minus 4y squared, x can actually be either the positive square root or the negative square root of the expression. Okay, so let's continue from here. So knowing that x is positive, it will take the positive square root. So therefore, the exact area of R would then be integrating, right? Maybe let me reread this. It will be the area of one rectangle x dy. I'm going to sum it by using integration. And now because it's with integrating respect to y, we need to see what are the limits of y. Okay, for R, the region R, the limits is y equals to 0 as well as y equals to 1/4. Okay, and we're going to continue from here. So this is equals to 0 to 1/4, 1 over square root 1 minus 4y squared dy. Okay, then I can rewrite this as a squared minus b squared under the square root, right? So let's take a recall on our integration techniques. The integral of 1 over square root a squared minus x squared dx is equals to sine inverse x over a plus c. Now, if you take a good look, right, x squared here has coefficient 1, but the coefficient of y here is of x squared is 1, so x is 1. So over here, y squared is equals to 4. So if the coefficient of y we're talking about is actually 2. So in order for us to make use of this formula directly, it is good to factorize the coefficient of y squared. So I'm going to do just that. So this is 0 to 1/4. 1 over square root, I'm going to factorize 4. So this is 1/4 minus y squared dy. Okay, and this will be half integrate 0 to 1/4, 1 over square root half square minus y square dy. So notice now I have changed the coefficient of y to be 1. Okay, I can apply the formula earlier. So this is half. This will give me sine inverse y over half from 0 to 1/4. This is equals to half sine inverse 2y from 0 to 1/4. This means this is half sine inverse 2 over 4 minus sine inverse 0, meaning this is half sine inverse half minus 0. Now remember, this is integration and differentiation. For calculus, all right, angles are in radians. So if you're looking at the angle 30 degrees, which is pi by 6 radian, sine of this is half, right? And that would be pi by 3 radians. So sine pi by 6 is half. Therefore, sine inverse half is equal to pi by 6. Okay, given that you are using sine inverse function, you need to work within the principal values. So this actually equals to half pi over 6, which is pi over 12 square units. All right, that is the area that we are looking at. Okay. Next, Let's look at the next part of the question. It says, calculate the exact volume of the solid obtained when r is rotated through 2 pi radians about the x-axis. So this is the axis of rotation, and 2 pi radian is the angle of rotation. Remember, for volume, you are told that you need to know these two. Now, why is that so? Now, it's still about r, but now it is about volume.